check, testing, 1, 2. Gee. All right, I think we have audio. I'm back to the headphones. My wife's on a meeting in the other room. You don't want to listen to that meeting. Oh, man. This is it. We are here at the end. We have survived. Good morning, everyone. Morning, Albert, Haley, Devante, Chantel, Christopher, all the usual gang. Oh, Devante, you have background noise. It's not letting me mute you. There you go. Where is all that sound coming from? Everyone is muted. That's so weird. I don't know. And so is anybody done with everything else? Like, is this like the last thing for anybody? No. So do you have other finals like this too? Like, are they also like submit? I think I asked this yesterday. I can't remember. Everyone is very tired today. No one wants to talk today.
I have like one more.
One more? Is it like this too, or is it like D2L or?
It's like a D12 Dropbox type of thing.
Okay.
Quiz test.
Gotcha. Mm-hmm. This is the time of year where I do not begrudge like a composition instructor. Awesome background. Brittany, I like it. Yeah, I don't begrudge the composition instructors where you have all these papers submitted, and I'm sure they have good methods for grading them. I struggle with grading writing. I've done writing in stats classes. I've had them turn in projects. It's just different. It's definitely not as objective as our work is, for sure. All right, well, what are we doing today? Today we are prepping for the final, so we can talk about whatever you want to talk about. The final's already slated to go. If I go to the news item, it is scheduled. It's going to pop up right after class. I think is there anything surprising here? Single page formula sheet, handwritten. Turn that in with your exam. Yeah, go ahead, Sandra. Yeah. Go ahead.
Oh, sorry to interrupt you.
No, it's
It has
fine.
nothing to do with the class, so it's a quick question.
It's fine.
Have you teach like statistic online before?
I have. Yeah, it's one of my favorite classes. I mean, I like teaching it in the classroom better. Everything's better in the classroom. But I've taught that online like, I don't know, 12 times or something. Yeah, teaching in the fall, actually.
Oh, wow. So you have some YouTube video available online?
Mm-hmm. Like 50. I have a whole website.
Oh, okay.
I have a whole website for that course.
Oh, wow. Okay, thank you. That's
email me. I can give you the link. You can actually you can probably just Google Dan Kernler statistics.
Oh, okay. Thank you. Thank you.
Yeah, I have. I bet we can just.
Okay. Thank you.
There's my YouTube. There we go. Oh no, that's not it. Shoot, that's the old one. Oh, you can't get to the. Okay. Anyway, I'll give you the link because it's right here. There's a whole like course page. All right. So, any questions? Okay. No problem. Any questions about?
Thank you. That was my question.
No problem. About the final, I did ask you, because it's the final, to write a statement on the top of your exam, or the end of it, whatever, somewhere in there, that just says, all the work shown is mine, and I'm only using the formula sheet, graphing calculator, and the decimals. That's the only change. So does anyone have any questions about what to expect, like kind of big picture about the final, or end of semester grading timelines, stuff like that?
The learner's supposed to write? Sorry about that.
Your audio is not great today, Tavante. Can you maybe type in the chat? Unfortunately, the audio is not great. And on the iPhone, I don't know how easy it is to type in the chat. If you have any questions while we wait for Tavante, you are welcome to email me clarification questions, deadlines. Even if you have a question about the exam, if we were in class, you would come up and talk to me and say, hey, can you, I don't understand number 8 or whatever, that's totally fine. So you can email me that, that's fine. It's right here. I put it on the front of the top page of the final as well, but it's right here. Zoom in a little bit. Just a statement that says that, why is it not zoomed in too much? Just a statement that says all the work's your own. You didn't ask anyone else for help, basically, and you used only these tools. And just kind of like a academic honesty statement, just to make sure that we're clear. This is a final, it's a big deal. So I just ask you to kind of sign your name, kind of, yep, I did this my own, and I only used those 3 tools there. That's all, just a little additional statement. If I don't see one, because it's new and you didn't see that, I might email you, hey, could you please submit, with the signed statement or something, but that's it. Just a little addition for this one. Any additional clarification questions about the exam or the end of the semester stuff? All right, I'm not seeing any. Feel free to jump in at any point if anything occurs to you. We talked yesterday kind of about the big picture, about the types of questions to expect and what could be on there, focusing on big ideas. And we have a variety of materials available. We have all the old exams. We have all the old study guides. And we have a Unit 5 study guide. So all of those are under the final exam folder. So there's a lot of stuff. Hopefully you've been digging around in there. And so today, the rest of today, our last day together, is just to kind of jump around and hit any requests that you have. So I will open the floor to any topics or specific items that you wanted to look at. And even a very general topic is fine. We can go look up and find a problem to work on together.
Can you go over example 4C from 5.5?
5.5 here, or from the notes?
On page 4. From the book.
From the book. Okay, hold on. I will open up the book, and that is not a problem. And you said 5.5, example 4C.
Yes.
Okay, all right, give me a second. Does not take too long. Let's see, okay, chapter 5.5. We're just gonna go there. All right, we're doing, these are all integration by substitution. These are indefinite integrals, okay, for C. All right, oh, that's a good one, I like that one. Okay, so we are doing the integral of e to the square root of x over the square root of x dx. All right, is this the right one, just to make sure?
Yes.
Okay, good, all right. So for me, We talked about this. We're going to have a bunch of integrals because that's chapter 5. So those are all going to be on there. And I'm not going to tell you use integration by substitution. So one of your challenges, how do I know when to use integration by substitution? The key for me is when I have one function inside another function. So this e to the square root of x is like e to the u. There's a substitution there. The square root of x is inside the exponential function. So what I'm going to do is I'm going to let u be the square root of x. And for derivatives and integrals, it's easier to write it as an exponent. It'll be x to the 1/2. Easier for me, at least. I'm going to find the differential du. That'll be the power rule, 1/2 x to the negative 1/2 dx. And then to do the substitution, I like to rewrite again back as a square root. You could do two things here. You could rewrite the integral with exponents, or you can rewrite the differential with square roots. For whatever reason, my pattern has always been to rewrite back in terms of square roots. Well, now looking at this integral, this is really the integral of e to the square root of x times 1 over square root of x dx. You can kind of split that fraction. Like a over b is the same as a times 1 over b. And now you can see we have the 1 over square root of x dx. We have an extra 1/2 though. So I'm going to multiply both sides by 2 and say 2 du equals 1 over square root of x dx. So now comes the substitution step. Square root of x was u, so this will be e to the u. And then the tricky part is the rest of it. Well, 1 over square root of x dx is 2 du. And so this is now just 2 times the integral of e to the u du, but we know that integral. That's e to the u plus your arbitrary constant, because when you take the derivative of a constant, it's 0. So there could have been a constant
Why
there.
are du always dropped off in the substitutions?
That's what so why is it dropped off when you have the integral of 2x dx? Why is it x squared? It's the same thing. Yeah, it's kind of a notational thing. It's kind of like the theory behind what the definite integral represents and what integrals represent. So it's a little abstract. It always does, though. It always does. So we'd have to kind of go back and kind of go through that theory of what that notation means.
But du just represents another form of dx.
Mm-hmm.
That's the gist of it. All right,
Yes,
thank you.
correct. Yep, you can kind of like, let me just quickly do a little sideline here. Like, so say we're looking at e to the integral of e to the x dx. That's the general antiderivative. That's e to the x plus c. But that letter is just a letter. So I could have e to the y dy, and that's e to the y plus c. Or I could have e to the q dq. Ooh, Dairy Queen. It's almost warm enough for Dairy Queen. E to the q plus c. Or they're just letters. So to your point, you're exactly right. If it's e to the u is just another letter. It's another variable, just like x. And so that would be e to the u plus c. So yeah, it's just like another, it's like just a different letter. So once you do that substitution, it's like you're resetting and you just have a new problem. And well, what's the antiderivative of that new problem? And it's just another symbol at that point. Yep. Cool. All right. Any other requests? We got a whole semester we could go to if there's some older stuff that you've been looking at that you wanted to review.
Talk about the squeeze theorem.
Mm-hmm. The idea behind the squeeze theorem, I'm going to try to draw a quick graph of it here. I'm going to draw two different graphs. So suppose I have a y equals f of x, and then I have a y equals g of x, and I'm intentionally making them touch there. And then I have some other function that's between them. And this is y equals h of x. And you can see clearly there's an interesting point here. We'll say this occurs at C. So clearly we have h of x is always between f of x and g of x. It's always between the two. And we have the limit as x goes to c of g of x is equal to the limit as x goes to c of f of x. They are both, whatever this limit is, we'll call it L. They're both L. Because they come together. Whoops, I'm kind of like doing opposite to that. So they come together and touch and then separate again. And so what the squeeze theorem says is therefore capitalized the wrong letter, that was weird. The squeeze theorem says that the limit of h of x as x goes to 0 is also, not as 0, as x goes to c is also L. So that the h of x is squeezed between the other ones. So I'm gonna see I'll give you a second to write this down. I'm gonna pull up a Desmos graph. We'll see if we can kind of understand what's happening here. Let me see if I can think of quickly on the spot. Ooh, man, I have an example in my mind, but it's like at infinity, and it's not. I don't know, the only one I can think of offhand is one that's at infinity. So I'm just going to do that one because that's all my brain can do right now. So this one, sine of x over x squared, kind of oscillates back and forth. We need to zoom in here. So we're going to do y goes from, we're going to make it really small here, 0.05 to 0.05. So it's really small, but you see it oscillates back and forth. That's a weird graph. And suppose I want to know what happens as x goes to infinity there, okay? So that's what I want to go. I'm going to put like x equals 30 here. Let's kind of see. I want to see what happens as x goes to infinity. Oh, Newton's method, Brittany, we said that one, we talked about it yesterday at some point. We don't actually have to know that one. We're going to leave that off. Yeah, so we're good with Newton's method. So it seems pretty clearly that this goes to 0, but what if I wanted to prove it? Well, what if I graph y equals 1 over x squared? And then I graph y equals negative 1 over x squared. Oh, well, that's kind of interesting. The red one is always between the blue one and the green one. Okay, well, we can actually prove that this first function's limit as x goes to infinity is 0. Now again, this is different than the drawing. The drawing I had the limit as x goes to a number c, and so it's just the only example I could think of in the spur of the moment. So let's say we're asked the question, limit as x goes to infinity of sine of x over x squared. And we were asked that. What is that limit? Well, here's what we're going to do. We're going to say sine of x is always between -1 and 1. Definitely. Sine of x always between -1 and 1. If x is not equal to 0, x squared is a positive number. So I'm going to divide all 3 parts of this inequality by x squared. And that should still be true. I wanted to say positive because remember when you divide by negative, you got to change the direction of the inequality. So here, if x squared is always positive, then that's totally valid. Well, so here's the inequality. That's my, I feel like I should get fancy here. I don't know if I can. This one, can I change the color of it? Oh, what color? Oh, shoot, what was it? It was on the Desmos. That's the green one. Okay, and then this one was the red one. Oh, shoot. This is not worth the time to do this, but now I'm committed. I have to continue. Okay, so the blue one is between the green one and the red one. Okay, so if we take the limit as x goes to infinity of -1 over x squared, as x goes to infinity, it becomes 1 over like an infinitely large number. That's going to go to 0. That one's clearly 0. And then the limit as x goes to infinity of +1 over x squared, also 0. So the power of the squeeze theorem is says, therefore, by the squeeze theorem, the limit as x goes to infinity of sine of x over x squared also equals 0. So the key there, to use the squeeze theorem, you have to have two things. You have to have your function between two other functions that you know, that you're able to analyze. And you have to have those two functions going to the same limit. Whether it's, as I did on the drawing above, the limit as you approach c, or in this quickly made up example here, the limit as x goes to infinity. Either way, you have to have those two outside functions going to the same limits.
Does it always have to be positive, negative for it to apply to the squeeze theorem?
No, good question. That only was here because the limit was 0. So the only way to get it squeezed, if we think the limit's 0, pretend those are touching. One has to be positive, one has to be negative. But we could just as easily do sine of x squared plus 2 plus 1 plus 1 plus 1. And then if I look up here and I change my y to up to 1.05, okay? Now, both of them are positive. It's just that one's above 1 and one's below 1, and then the other one's kind of oscillating above and below 1. So the positive negative was only because we thought the limit was 0 here. And so if we think the limit's 0, then I have to find one that's positive and then one that's negative and get them kind of squeezing together. All right. Does that help, Haley? That was your question originally?
Yes, thank you.
Okay, you're very welcome. Very welcome. So that was an early limit topic there from chapter 1, chapter 2, chapter 1. It's been a while. I know we actually, the only reason, the main reason why we used the squeeze theorem, you don't remember this, but was to actually derive the limit for that was needed in the derivative of sine of x. That was why we needed it way back in the day. All right, that was a good one. Any other particular requests?
Can you go over the process of finding a limit at infinity of a polynomial?
I think, do you mean a rational function? Because the limit of infinity of a polynomial is just going to be, it's just going to be infinite. Unless there's some negative signs. But I'm just going to look at the first term. Well, that's positive, so as I go to a positive infinity, that's infinity. But did you mean like dividing, like a rational function?
No, I remember the rational function. I just wanted the
Okay.
polynomial.
Yeah, so basically what you're going to do for a polynomial is you're just going to focus on the leading term, because the rest of it, as x goes to infinity, the rest of it's going to be smaller. So what we're really talking about here is we're really talking about end behavior. This is what I talk about with my college algebra students. And so it's all about, are you going to positive or negative infinity? Positive or negative infinity. And then the exponent and the coefficient. And it's that like combination. So if you're going to positive infinity, then x to that power will always be positive. And then you have a, the sign of a will determine whether you're going up or down. So if I take the limit as x goes to infinity of -4x to the 6th plus a bunch of other stuff, well, that's negative infinity because x to the 6th goes to infinity, but we have a -4 in front. For negative infinity, you got to be a little careful because it depends on whether the exponent is even or odd. So I could have -4x to the 6th here again. but x to the 6th will be positive because it's 6. And then the negative in front keeps that going to negative infinity. And you can even see that on graphs. Y equals negative 4x to the 6th, 6 plus whatever, doesn't matter, 5x cubed minus 3x plus 4. Doesn't matter, it's going down in both directions, down, 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 down. Because whether you're going to positive infinity or negative infinity, either way, the x to the 6th is positive, and then you have a negative 4 being multiplied by. So it's all about that leading term, whatever that exponent is it even or odd, and then the coefficient, whether that's positive or negative. Does that answer your question?
Yes, thank you.
All right, Devante, good question about optimization. So the downside, there's a positive and a negative for so I have to like sound out the word optimization. The positive thing is here, it's a relatively consistent process. One, you have to find a function for what you're trying to optimize, whether you're trying to find the biggest or smallest. And then two, this is almost universally, you use a second fact, which becomes an equation, to rewrite your function, because your function must be a function of just one variable. So to rewrite your function, so it only has one variable. Okay, so use a second equation to rewrite your function so it only has one variable. And then third, you just find the critical number, set the first derivative equal to 0. Yeah, I see your second comment, Devante. That's the rational ones. We can do that next. So this is the general process for all optimizations. You got to find a function for the thing you're trying to optimize. You use a second equation to rewrite that so it only has one variable. And then third, now you have a function, and so you just take its derivative, set it equal to 0, find the critical points. So that's the good thing, is it's a consistent process. The bad thing is we could do 8 different problems right now, and I could still give you a new one that's different on the exam. Because they used, if you recall, I think we should have some notes here, right? What section was that? Optimization.
Chapter 4.
Which one?
It was chapter 4.
Yeah, chapter 4.
I think section 4.7.
7. Here we go.
to
I found it.
4.7.
I found it. Oh, we didn't do the examples. We must have just had lots of homework questions. So here we did maximizing area. So it was a rectangle, length times width. And then we did maximizing the cost of a can. So we had volume, and then we had this like cost function that we had to make up. Then we did perimeter of a rectangle, kind of, but it had another fence. So it's kind of a rectangle. Surface area of a box. So it's volume, and then we had surface area. I feel like there was a triangle one too at one point. I think there might be more homework questions in here somewhere. I feel like there were more in here somewhere. 421. Yep, here's another optimization one. Find the coordinates that are closest to the point. So we use the distance formula. Here we use this angle. Whew. So my point of this is not to really, I don't mean to stress you out and overwhelm you, but the problem is that like we could do another example, but there's no like really, here's how you memorize optimization. It's all about making sure you understand that process, and then what I would do if you really want to be prepared for these, first of all, I would say that optimization is one topic. There are 200 points on this exam. An optimization question would be at most 10. So if it were me, and I was really nervous about that section and did not understand it at all, I would save it for studying for last, kind of focus on things I'm more comfortable with and really get good with those. And then kind of do that at the end. And when I'm ready to go, just go. If I don't totally get it, I don't totally get it. It's 10 points. It's okay. Like don't, because you could spend 2 hours doing a bunch of these problems and then you're burning away time for other questions that you could have gotten more comfortable with. So I just want to say, like, it's tough. It's tough to, I understand it's a challenging section. The best way to learn how to do it is to like re-look at the examples that were in the videos that we did in class, because we have those YouTube videos are still up. If you want to make a note of them, what date was that? April 21st. We did 3, 4, 5. We did 5 examples on April 21st, and then 1 more on April 23rd. So April 21st and April 23rd would be good replays to look at and try those examples, those homework examples again on your own. Because it's building, you know, some common things. You did area, length, width, you perimeter. We did volume of a box was a common one. Cylinder was one that came up. You have volume of a box, of course, is length, width, height, and then you have surface area. Is you have all the 6 sides. So you have 2 length, width, 2 width, height, and 2 length, height. Volume of a cylinder is pi r squared times height. And surface area, we didn't really do surface area. We did like a cost function, I remember, and that was one we were just looking at, which was basically surface area, kind of modified. There's 2 bases, so it's 2 pi r squared. And then the area around the outside is actually just if you slice it and open it up, it's just a rectangle. And the height is the height of the cylinder. And the width of the rectangle is actually the circumference of the circle, 2 pi r. So there's surface area. So those were the common like geometric ones. And then I remember using some triangles. Where's the one? We did the spotlight on the shore. Why can't I find that one?
That was earlier, like 4.1 or 4.2. That was one of those examples.
That was related rates.
Yeah.
Yes. I'm like confusing the 2 applications from that chapter. It was not an optimization. Yes, that was a related rate. So optimization, I think those were the main ones. I'm thinking of related rates. There were some triangle ones, but not optimization. Usually we're trying to optimize area, get the largest one, minimize cost of producing a box or producing a can. So I think those are the most common ones. So make some notes. You know, these are maybe good things to note. A cylinder is a common shape to analyze. Yeah, I think that's probably our best review for those. We can maybe look at one example and just kind of talk through, well, here's one we haven't done. We could do this one. This is one I'm really sad, because this is one that I have an activity where we do in class where we actually take pieces of paper and try to make the biggest box we can. And then we record, we have rulers and scissors and tape, and we like record all of our measurements and we put it all up on the board and we say who can make the biggest box. It's like one of my favorite days. We burn a whole day doing it. It's really fun. Now we're gonna take 5 minutes. Ooh. Okay, so we're gonna imagine we're making a box. It's not a really functional box. It's a piece of paper, and we're gonna fold up the sides and kind of like cut a square out of each corner and then fold up, and then like tape around the corners, tape, 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 to get this really, really flimsy box made out of paper. So the challenge is we want to get the largest volume. We want to get the largest volume, okay? So you can see here we have this width and and length. The volume is going to be width times length times, and then the height is x. Because that was the little piece we cut out and then folded up. So the height is the little piece we cut out. That's x. Well, somehow we have to get W and L both in terms of x. Does anyone know what the dimensions of a standard piece of paper are?
8.5 by 11.
So this should be the full, that's correct. This should be 8.5 inches over here, and this full distance will be 11 inches. So if we cut out 2 squares, what's that remaining short side going to be?
$2x.
There's a 2x involved.
8.5 minus 2x.
Minus 2x, right? Yep, it's the 8.5, and then you took out 2 x's. That's correct. And then same thing for the other one down here. This one down here will also be the same idea, 11 minus 2x. She just wanted to help, Chantel. She's just trying to be helpful. So we have our width, we'll call it, is the wide one, 11 minus 2x, and our length is 8.5 minus 2x. The key for that one, Tavante, is we cut out an x from the corner and an x from the other corner, and then we're folding kind of along this dotted line. So if the full is 8.5, then this remainder must be 8.5 minus 2x, because we took out we cut 2 corners out. So now I have a volume function with it, which is width 11 minus 2x, length 8.5 minus 2x, and its height is x. And that's a little tedious, but that's just a polynomial. So we can multiply it out. Let's see, 11 times 8. Hold on. It's too early to be doing this much math. 11 times 8.5, I should be able to do that in my head, but so it's 93.5, and then minus 22x minus 17x plus 4x squared times x. And let's see, 93.5x. Let's see, those two would make negative 39x, but then I'm distributing another x, so negative 39x squared, and then 4x cubed. You can check my algebra there. Basically, we just want to multiply it out. So I don't know, does anybody have any concerns there? Any questions so far? Tavante, I'm sorry I didn't follow up with yours. Is that clear where the 2x comes from?
I have a question.
Yeah, go ahead, Chantal.
So Dr. Sugar, she did one for as an example for this, talking about like a bag of chip box, but she didn't multiply it out.
Okay.
We were trying to find the maximum volume. She left them as like the 11 minus 2x and then set each one to 0. Typically one of them, when you set to 0, like it comes up with a negative number or something that's just not feasible, and you just go with the other one. Is that okay, or do you want us to multiply it out like that?
I think we might have to look at the context. So when you're setting, I think what she's doing is kind of an extra step that's really valuable. What she's doing is saying, well, let's find out the boundary points, like what the smallest x could be and what the largest x could be, like those maximum values. So that would be when the volume is 0. Like if you don't cut out anything, if x is 0, you just have a flat piece of paper. The volume is 0. And then if you cut out too much, you like, all you have is a like can you imagine, I'm trying to get like a piece of paper here. It's not really blank, but anyway. So if you cut out too much, you're just gonna have like old piece of paper left because there's no sides. So what she's doing is she's finding the boundary points, like the minimum and maximum x values. So that would be when these volume is 0. So you can't, I guess this one would be what x equals, so 4 1/4 would be the most you could cut out, and then 0 would be the least. Those aren't going to be the maximums. When you set the volume equal to 0, those aren't going to be the maximums. They're not going to give you the maximum volume. They're going to be like the limits on the x values that you can cut out. But they're not going to be the optimization point, which is on the curve. It's like that peak up there. We'll talk about those. We'll come back to those. Those will be relevant. I'm glad you mentioned that. Those will be relevant, but they're not going to give us the biggest volume. And I'll talk about how I know in a second. So now, remember our process. Oh, it's on a different page. I don't want to go to the other page. It's on a different page. Our process was you get a function that you want to optimize, use another fact to get it in terms of one variable. So our other fact we used was that we were cutting it from a standard page and we know the dimensions, 8.5 by 11. That's the other fact. So now I have it as a single variable. Now I'm going to take its derivative and set it equal to 0. 93.5 minus 78x plus 12x squared. And I want to set that equal to 0. I don't want to try to bother factoring that. So I am going to use the quadratic formula. Right, so the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. And remember the a and c are kind of in the wrong spots here because it's in the wrong order. We got to switch those. So let me get a calculator up. Desmos again. Scientific. Let's see if I can. Not loading. See if I can show. Okay. So we have a quote. We have 78 plus the square root of, I'm just going to do 78 squared because it's squared, so it doesn't matter. That's negative. Minus 4 times 12 times 93.5 over 24. I'm not going to do the minus. Ooh, that's not good. There is something wrong with our math here because we got 4.9. Somewhere we have made a mistake because that's, if we cut out 4.9, that would be almost 10 inches that we would cut out, but there's only 8.5 inches on that short side. Uh-oh. Did I type something in wrong? Oh no. Somewhere we have made a mistake. I don't know where it is. See, let me just go back to this. Let me graph the original equation. Let's see if we can figure out what's happening here. Y equals 93, actually, let's do the original one. 11.11 minus 2x. 8.5 minus 2x and x. So we need to make our y a little bit bigger. Let's try 50. Not big enough. Let's try 100. Okay. So you can see right here, do you see the 4.25 there? That was where the volume was 0. Because if you cut out 4.25, you double it, that's 8.5. There's nothing left. So that's our 0. So there is a peak in the middle here. at 1.585. So there is an x value that gives you a maximum. And why are we missing it? There's the 4.915. Oh, maybe we should do the subtraction. I'm kind of assuming that it was going to be negative. Oh, that's all it is. So that one's outside of our scope. If I do subtraction, 78 minus, oh, there it is. There it is. We just kind of went too quickly and only did the positive, but the negative 1.585. So x is approximately equal to we'll call it 5.9 inches, or approximately, what was it, 4.9 something inches, but this is too big. So the maximum volume is when we cut out 1.59 inches. So the part where you were setting the v equal to 0, where Dr. Sherger was doing that, is getting you that 0 and the 4.25, which are important. And they became important at the end when I went too quickly and was like, oh no, it's not possible because the 4.9 is too big. It's 0 volume, it's outside of our scope. But then we figured it out. We needed to do both of them from the quadratic formula. And you can see, here's that 0. So we're only interested, in fact, we could even just only graph this from 0 until 4.25, because that's the only relevant part. And so that's really the only part of it that we care about. And here's our maximum. So almost 2 inches, or like a little over 1.5 inches would be the box to cut out that would give you, or the square to cut out that would give you the largest box. So this example here, this example is just one of many, but it's the process is pretty typical. You have an equation that you're trying to optimize, a function you're trying to optimize. Our volume, we're trying to find the biggest volume. You use, in this case, the fact that it was a standard piece of paper, so you use some other fact to get it in terms of a single variable. You take its derivative and set it equal to 0, and then you have your answer. And in this case, there was a little extra layer of like analysis because there was some logical limits to it because of the boundaries there. So we could, and we're not going to do any more of those because we could spend all day doing. We could spend like 4 hours doing, and every example would be different. So this process is going to be the key. If you get stuck, I would say write down what you would do for the rest of the problem. Kind of gain some points for saying, hey, I have some good notes. Here's what my note says, or here's what I remember about the process if you get stuck. And then you'll notice, you see, how did I figure it out? How did I figure out what went wrong? You think about what I did?
You realize that you only did the one version rather than taking both
Yeah.
plus and minus.
And I don't know if anybody remembers, but I caught it when I graphed it. That's where I'm like, well, I know there's another one here. And I realized it when we didn't have the limitation. And I was like, looked at this minimum, I was like, oh, there's the 4.9. Oh, I didn't do the minus. So the graph was really helpful. And so I would encourage you to, whenever you can, do a graph too. Use that as some additional information. There was another question I want to just talk about quickly that Tavante had asked about, and it was about limits at infinity. We were talking about this a little bit earlier with Christopher, and he said he was okay with this kind, but it's worth revisiting, of a rational function. So I'm gonna call this ax to the n plus some other stuff over bx to the m plus some other stuff. So when you have a ratio like this, only the highest exponent matters. And so there are three cases. One, if the denominator was larger than the numerator, if the exponent in the denominator is larger than the exponent of the numerator, that limit as x goes to infinity equals 0. You can graph it and watch what happens. And if the denominator is bigger, it's going to go to 0. Maybe it could be negative, could be positive, but it's going to go to 0. If they're equal, then the limit as x goes to infinity of that thing will just be the coefficients, a over b. And then if the numerator is larger than the denominator, so if the x to the n, if that n is exponent is larger than the denominator exponent, then you get an infinite limit. And it can be infinity or it can be negative infinity. It depends on the problem. So that's what you were thinking of, Devontae. That was good memory. I think you had a pretty good, I think you summarized it good in your chat comment. Yeah, sounds good. No problem. Okay. Anybody else got anything that you've been thinking about that you wanted to ask about? Yeah, some of it's like, man, I'm just ready to be done.
You were serious about the 200 points, weren't you?
So this is like, when you think about our exam, if you think about during the regular semester, we were going to have the first part yesterday and then the second part tomorrow. So we were going to do 2 exams that are like regular exams. Now, the point value on the exam is kind of irrelevant. I could have it worth 20 points and then just take off like quarter points or things like that, because it's all about what does it count for your grade. And for your grade, since we're on the percentage-based system, the final is, I believe it's 20%.
I think your rubric said 25%.
25%. It's not the same for all of my classes. So that's really the important part. Did I do? Oh, I don't have the original syllabus. This is like the updated syllabus. Oh, but yeah, we should look at that now. I don't know why I got rid of the original one. Let's just get it up here now so we can clarify. I think you're right. So the point is, though, that it's a percentage of your grade. And so the point value on the exam is kind of irrelevant. It's just a way for me to distribute some points. And I like the 200 only because it reminds you that it's like double. And you'll see it's going to be twice as long as a regular one. So Devontae says 20%. 25% is a lot. And I don't know, I'm going to write a note to myself. You should have both syllabi up there. So I'm going to repost the original syllabus just so you have both of them. Because they're both valid, right? They're both still in play. Right? So let's take a look here. Oh, 25. Brittany was right, 25. The homework and quizzes and all that is 20%. The exams are 55%. So if you think of the exams, we have 4 unit exams. So if you divide that 55 by 4, that's like 12, 13. And if you double that, that's basically 25%. So the final basically weighs as much as 2 regular exams, roughly. So I understand it's a ton of pressure. So, do your best. I understand also that it's been a crazy semester. Also, I have this kind of buffer here for people who've been working hard, asking questions, being involved. This counts early in the semester too. Yeah, so that 1% is just, it's not going to help you if you end up at 74%. That's not going to get you a B. It's 1%, not 6%, 1%. So that's just for people who are at the end of the semester. They're at 79%, but they worked really hard. They came to class to ask questions. You remember from when we were in campus who those people are. And then some people were quiet but came to my office and kind of just, some people, since we've been at home, have been emailing me a lot. Like all those things count. You just show that it's really important to you and you're asking questions and you're involved. I say, you know what, wow, that student worked really hard, then they'll get that 1% buffer at the end. And it's usually like 2 or 3 students. Most students end up have a solid, they're right in the letter grade. So this is only for students that are right at the border for the next letter grade where this would matter. Yeah. Lorenzo, go ahead. Are you there, Lorenzo?
Oh, hi.
Go ahead. You had your hand raised.
Yeah. But I had a question about the I think it was 2 theorems. It was like I know one of them was the mean value theorem, and then there was another one.
Let's see. There's the mean value theorem. There's Rolle's theorem. Is that the other one you're thinking of?
I think so. I know we did both of them on the same. It was in the same like.
Yes. Okay, that's the 2. Yep.
Yeah.
So.
Yeah.
Yep. All right. Rolle's theorem is you have a function and it has to start and end at the same point. And if it's a nice and smooth function, there must be some point in the middle where the derivative is 0. If it's nice and smooth, that's the only way. So if it's technically the term is if it's differentiable. So if it's differentiable, then if you have f of a equals f of b, and f is differentiable, so no sharp corners and continuous, well then there must be a c where f prime of c is equal to 0. It has to have a horizontal tangent line somewhere in the middle. And then the mean value theorem is basically a more flexible version of that. And it says if you start at A, actually let me do one that's a little more interesting. I'm gonna do one that kind of loops down and then goes up. This might be too fancy. Hold on. We're gonna do like this. That's what we want. I want it like an S. Okay, A, B. Now again, F must be differentiable. Nice and smooth, no cusps, right? No corners. Differentiable. What this one says is, well, you have this secant line between the ends, and the slope of that secant line is just the slope between 2 points, change in y over change in x. There must be at least one point where the tangent line is parallel to that. And in this case, there are actually 2 of them. Maybe around here, call it C1, and maybe here, C2. So there must be at least one C where f prime of C, the derivative at C, the slope of the tangent line at C, is equal to the slope between those endpoints. So in this case, actually there are 2 of them, but the theorem guarantees 1. Theorem guarantees 1. All right, does that help for those?
Yes.
That was unconvincing.
Oh, sorry. I was writing things down.
Okay. I was like, yeah. No, I get it. You were concentrating on writing. Okay, cool. Chantel asked what is the time limit? The time limit is it will be open in 15 minutes. It's going to pop up at 10:45, and it's due at midnight tomorrow. So if you wanted to, and you're done with your studying, you're like, yep, I'm ready. You can open it at 10:45, and you have 24, 36, 37 and a quarter hours is your time limit. So what I mean is, once you start, I'm not clocking you for how long it takes you. It just has a due date. So.
Okay, that was my question because I've been doing like the final exams as if we only had the class time to do it. So being that this was supposed to be 2 classes. I didn't know if like we had like a 3-hour
Right.
time limit to get it done.
Yeah, so normally we would do it like that, you know, we would usually have, we've been given a little extra time. We did that when we had our face-to-face classes. We stayed until like 10:45, so we had an hour 15. I'm kind of writing it where I think the students who are most prepared will finish in 2 hours or under. But I don't care if you take 4. Okay, so it's not timed. Yeah, especially when you have interruptions. So it's all good. Don't worry about that. Don't time yourself. I want to see your best work. You know, considering the situation, everything that's going on, we're kind of like compensating for that by giving extra time. So don't worry about time. Don't wait until like, you know, oh, I have 3 hours, so I'll start at 9 o'clock tomorrow. You will be so stressed that will not go well. So absolutely do not do that. But you don't need to start right after class if you don't want to. Or if you want to, you're like, man, I'm ready to be done. So I'm like hitting refresh at 10:43, 10:44 until that thing pops up because you want to get started. I get it too. That's totally fine. All right. Any other questions?
Will you be closing your D2O access immediately after tomorrow, after the course is up?
Yeah, I don't intend to. I usually leave it until the end of May, but I don't know if I've changed the settings yet. So let me check. I have not, so I'm going to change it because it's fine. I don't care if you can get in, and then you can, you know, after this, because I'll post an announcement there when grades are up, and so yeah, so it'll be open for another couple weeks after. I have one final that's going to be turned in tomorrow afternoon from another class, so I'm going to start grading that. I have yours plus my 2 Calc 3 classes are all due tomorrow at midnight. So that means my Thursday and Friday are heavy grading. So I'd like to be done by Friday and get everything in. So, you know, if you're not yet, hopefully you are already, but you can subscribe to notifications. Click on your picture, or I think it's just like a blank face up here if you don't have a picture, and do notifications. And then you can subscribe to get emailed about news posts if you haven't already done that. And so, or you can just keep coming back and hit refresh. But I'll put a news post once grades are updated. And you should see everything there. If anybody's missing, if you're looking for extra points, you maybe check, I think everybody here has them in, but make sure you have those 2 reflections. You see I'm missing 9 reflections from the 2 exams that were at a distance. So you can still do those if you want, get some extra points there. They're treated as quizzes. They're in the same category. So that's some good points there. All right. Well, before we go, I just want to say that, like, I have been so impressed with how, like, you all have done. Especially, I know, like, the transition is awkward for a variety of reasons, but I know I got some feedback in the surveys about it's kind of hard to switch to somebody else's videos and notes, and you know, and I get it. I wish we could do mine too. Mine are definitely better. They're not better at all. Dr. Sugar's great, but, like, you know, it's been super awkward. And we're meeting twice a week for an hour, and we're trying to answer questions, and you're like trying to like figure out how to use your phone to like submit stuff. But the quality of work that I'm seeing is like really good, really good. And you're just like, I'm getting all emotional. Like, it's just been a really impressive for how hard you've worked with everything going on, and you're continuing to ask questions and stay involved, and you're trying to make the best of it. And I just want to let you know that I really respect that and really appreciate that. That's all. I just wanted to let you know. Oh, Tavante's got his hand raised. Uh-oh.
Oh yeah, I was gonna say, like, it was hard, like, learning from 2 different teachers, like there's 2 different teaching styles. I don't know. It's just
Definitely.
confusing.
Yeah, definitely. Yeah, and it's not how, like, Like when I'm prepping for fall, I'm going to be making all my own videos for whatever classes I teach for fall, you know. So I get it. It was just kind of an emergency. It's what we had to do for sure.
For calculus 2 for the fall.
I'm still debating.
I knew
Sorry. I'm sorry. Lorenzo, you going to add something?
Oh yeah. Oh no, I don't know. 'Cause like, yeah, it was hard to learn from like two different teachers, but like from two different like, you know,
No
videos. But
style.
yeah, but I don't know. Compared to some of my other teachers, I feel like you did a better job of transitioning than a lot of my other ones. 'Cause my other ones,
Yeah,
we didn't even meet up
definitely.
at all, or like she didn't really came in contact with us at all.
Yeah, I feel so
Yeah.
bad for everybody, you know, um, because like I feel bad for you because you didn't sign up to be online students, and you know, but I also feel bad for my colleagues who like, you know, this has been hard for me, but I've taught online before. I have I have two computers. I have a brand new tablet with a pen that I can write. I have software that not everybody else has. I have experience doing this kind of thing before. Um, I have a freaking green screen with extra lights. So the only reason why it looks so clear is because I have extra lights. You see that light over there? Bright light shining on the green screen to make it work. And then there's another bright light over here. And then I have a light on my face because I know about lighting. I mean, this is not normal, right? And so it's just fun for me, but it's just different. And I feel bad. Like some of my colleagues, I remember when we had a meeting after, I think I told you the story already, but after that Friday, we said, oh, we're going to be off for 2 weeks, right? 2 weeks. And then Monday, they let us come back to campus. So we came back to campus. We had a meeting. After the meeting, one of my colleagues, who's a retired high school teacher, was crying, just crying. She had never used D2L, had never used online homework before. Had no idea how to do any of it. And so, you know, part of it is like, I feel like it sucks for you because like, I'm not getting anything from my teacher. What am I doing? What's happening? What's going on? And then I feel bad for them because I mean, maybe there are some who are just like, hold on. And then they're just like, I'm out, you know? Maybe. I really doubt it though. I think most like, I don't know what to do. Like, how can I do it? I'm like learning new things. And like, we have these flurries of emails and people coming around and trying to figure out what to do. And, you know, so most of them, I just feel when you're not getting that from them, it's not because they don't care. They just don't know. Don't know what to do and didn't know what to do. And so, you know, I feel glad that I was able to give more, you know, give more support and try to make it as normal as possible. Just considering. So, yeah, but it's been tough. I'm like emotionally exhausted. I'm just like tapped, you know. So I can't imagine how you all feel too. Devontae, I'm not teaching stats in the summer. There's a couple other, there is an online stats though. There's a Mth120 in the summer, but I'm not teaching it. I'm teaching in the fall. That one I'll keep. I'm not going to switch that one because I've already taught that one online. So I'm good. I'm good with that one. It's a good class. So.
Have they said anything about, I know the governor made a announcement about the Restore Illinois plan.
Mm-hmm.
Is the school planning to making contingencies for that? Because
Yeah,
it sounds like
so
we're not going to be doing anything.
they don't want to decide early. So they're meeting today. There's a meeting with our like the boss of my boss. So the vice president of the teaching side of the college. There's a meeting of all of those across the state of community colleges to kind of talk about, you know, what should we do? What should we have for the fall? The community colleges really are tied to the local schools as well. That's why we like all close on snow days at the same time, because if we're on and the schools are off, we have lots of parents on staff and as students. How do we, if our kids are off, how do I teach? Or if your kids are off, how do you go to class? And so we usually tie, so it's going to be difficult because the high schools or the schools are probably not going to have their guidance until July. They've been told by ISB, Illinois School, whatever. One of the I something acronyms, the state school board. So we got a long email yesterday from our vice president that said they're going to try to decide by early June to try to make a decision. My guess is, based on what I've heard, is that lab-based classes, they'll try to like do small class sizes or half classes on Monday, Tuesday, Wednesday, Thursday, or something like that to do the labs, and that everyone else will be online. That would be my guess if I had to bet, just to reduce risk, because nothing's going to be different in the fall. We're not going to be at herd immunity. We're not going to have 60% of the population have gotten it or have recovered already. We're not going to have the vaccine yet, and the medicines are still getting tested. So not much is going to be different in the fall. And you can't have social distancing in a class of 28 people in a classroom. You just can't. So that's why my suspicion is that, if I had to bet, that math classes will probably be online in the fall. But I don't know. Maybe it'll turn out, and once they have a lot more data, that way more people have had it than they thought, and we're just asymptomatic. And now look, 45% of the population have already had it because we have tests and we've given tests to all these people. Oh, maybe we'll just, I don't know. But that's what I've heard. That's all I know. I feel like that, like, teenage phone call or like video message where you don't want to be the one to hang up. That's what I feel right now. Right? No, you hang up. No, you hang up. Oh my gosh.
I have another question.
Sure,
It's not
Sandra.
related to classes or
Okay.
anything. Last time I went to a meeting and the president and other people were talking about some fund money received from the government for for community colleges, and one part is for student and the other part is for the business part, keeping everything up.
Mm-hmm.
And I don't know if you have any information about that fund.
I don't. No. The only thing I'm aware of is like the one that was sent to everybody, the CARES fund. Not everybody, but was sent to all Americans who had tax returns in 2018 or whatever it was. That one, and then there's a local ECC fund that I've donated to. That was for ECC students. That one I've posted about before. So I'm not sure about that one. I feel like I remember hearing about it maybe once, but I don't know that the law actually passed. Was it? Did Dr. Sam say that?
Yes,
Okay.
that was 2 weeks ago, and they said that they received the money. They already received the money, but they, making decision of how to distribute stuff like that.
Yeah, that one I don't know anything about. That one, I'm sorry.
Okay.
Yeah. All right, everybody. Well, this is it. You have the exam will be posted probably pretty much after we hang up. You can email me questions that are about like exam clarification questions. You can post them in the Discord if you want to, so everybody sees them. If it's important enough where it like makes a big difference, like, oh yeah, that's confusing, I should clarify that, I'll post it in the Discord or on D2L so everyone can see it. But you cannot ask me like, can we go over more of topic X? It's too late for that. You can kind of consider that the exam has started now. So, cool. All right. Best of luck on the rest of your finals and getting all your papers in and all that. And thanks for a great semester.
Thank you.
All right,
You're
thank
welcome.
you.
All right. Take care, everybody.
Bye.